Hey guys, Jake here, coming at you with some more math today. Today I'm going to be showing you how to solve this problem right here, so stick around and let's get into it. The problem is find dy dx by implicit differentiation, and this is the equation that we're given. Really all we're going to be doing here is just applying implicit differentiation to this problem and then solving for dy dx. So first thing you want to think about when you look at a problem like this is the fact that this here says we're looking for dy dx. And the reason why this is important to notice is you want to think about what variables are in the numerator and which are in the denominator of this term here. So we're told to find dy over dx, which just means the derivative of y with respect to x. So what that tells us is y, the variable on top, is actually a function of x because it's the variable on the bottom. So this indicator here on the bottom, the dx being on the bottom, tells us that we're taking the derivative of this whole thing with respect to x. So what that means is y will be treated as a function and x will be treated as the independent variable that we're taking the derivative with respect to. So all that means is since we have this equation that has x's and y's in it, and we need to find dy dx, all we need to do is take the derivative with respect to x of both sides of our equation. So let's start over here on the left side, and we'll just kind of go term by term. So first of all, this first term here, the derivative of x squared with respect to x, to find that we just need to use the power rule, right? Because this only has an x in it. This dx here tells us that x is our independent variable. So to do this, we can just do power rule. So we can bring the 2 down in front and lower the power by 1. So that would bring the 2 down in front. 2 minus 1 is just 1. X to the first power is just x. So this is just going to be 2x. Now this second term here is going to be a little bit more complicated because notice we have negative 4x times y. So because we have an x being multiplied by a y, we're going to have to do something a little bit more complicated, which is to use the product rule. So we have to use the product rule because you have to use the product rule whenever you're taking the derivative of, one thing times another thing. There is a little bit of freedom in what you want to call the first function and what you can call the second function. But just to make things, kind of easy on us, let's just go ahead and say that 4x will be one function and y will be our other function. So product rule says the derivative of 4x times y would just be, so keep in mind we need to put parentheses around this because we're subtracting this whole thing. So to find the derivative of this, we'll just do the product rule, which just says we will take the first function, so 4x, times the derivative of the second function. So the derivative of y with respect to x is just going to be dy dx. And that pretty much is just by definition of what dy dx means. It literally just means the derivative of y with respect to x. So since y is a function of x, we're taking the derivative of y with respect to x. The derivative of y is just going to be dy dx. Okay, and then product rule says we need to then add the derivative of the first function times the second. So the derivative of 4x is just 4 because we're taking the derivative with respect to x. Since x is our variable, the derivative of 4x is just 4. And then times our second function left alone, so times y. So this inside the brackets here is the derivative of 4xy. Remember, we're subtracting, so that negative is just going to hang out in front there. Now we need to take the derivative of y squared with respect to x. So again, since we are taking the derivative of some y with respect to x, that tells us that y is obviously not the variable here. Y is a function of x. So what you want to think about, y squared is y is some function of x. So this would be like taking the derivative of some function of x squared. if you had something like this, something in parentheses with a bunch of x's here, and you took the derivative of this whole thing, you have to use chain rule, right? Because we have one function, our f of x, our inside function, being plugged into another function, which is the piece that's squaring it. So because we have y being a function of x, y squared requires the chain rule because we have one function inside of another function. So the chain rule says that we will take the derivative of the outside. So first you want to think about what your inside function is. Our inside function is just y, which is some function of x. So we're going to take the derivative of our outside function, which is everything outside of that y, leave the inside alone, and then multiply it by the derivative of the inside. So to do that with respect to x, we'll take the derivative of the outside, which is this squared piece here. So that would just be power rule. All right, so we'll move the 2 down in front, leave the inside function alone, which is our y. We don't touch y yet. Lower the power by 1, which would just be the first power, which doesn't really do anything. And then we'll multiply that by the derivative of the inside. So the inside is y. The derivative of y with respect to x is dy dx. So 2y dy dx is the derivative of y when we're taking the derivative with respect to x. And then we'll keep over on our other side of our equation, the derivative of a constant is just 0. Okay, so now we've taken the derivative, we've applied our implicit differentiation. Now all we need to do is solve for dy dx. So notice we have a dy dx here and here. So essentially all we need to do is get the dy dx by itself. To do that, usually what you want to do with these kind of problems is, kind of expand everything out, get all your dy dx terms on one side of the equation, everything else on the other side, and then you can factor out a dy dx. So then there's only one of them to solve for. So let's go ahead and do that. First, we'll expand everything out. So this minus, this negative sign is going to distribute to that term and that term. So we're going to get 2x minus 4x dy dx, and then minus 4y. And then this is all simplified as much as it's going to be. And it's all going to equal 0. So then we can move everything that doesn't have a dy dx in it over to the other side. So we'll subtract 2x. This has a dy dx in it, so we'll leave it there. We want to get rid of the 4y, so we'll add that over to the other side. And then this term here has dy dx in it, so we'll leave that here. So that gives us negative 4x dy dx will stay. The 2y dy dx will stay. And then over on the other side, we're going to have negative 2x and positive 4y. Okay? So I'm just going to write this higher up here. Okay, so now, since everything on the left side of our equation has a dy dx term in it, and everything on the other side doesn't, what we can do now is factor out our dy dx from this side of the equation, and then we'll kind of simplify things in terms of our dy dx. So let me show you what I mean by that. So notice we have basically two terms over here. One here, and one here. They both have a dy dx, so we can factor that out. And then you want to think about if you pulled the dy dx out of this term, what would be left? So if we took the dy dx out, we would just have negative 4x. And if we took the dy dx out of this term, we would just have plus 2y. And then this side is going to still be the same. Okay, so now if we want to get our dy dx by itself, we just have dy dx times a bunch of other stuff. So if we want to cancel out all this other stuff, we just have to divide it over to the other side. So we'll just divide both sides by negative 4x plus 2y. That'll cancel that. And then over here, we'll just get negative 4x plus 2y. And then interestingly enough, every term is divisible by 2. So we could think about pulling a 2 out of each term on the numerator, and we could pull a 2 out of each term on the denominator, and they'll actually cancel out. So essentially, that's just going to do something like this. So we'll pull a 2 out of our numerator. This term here will still be left with negative x. This term will be left with plus 2y. Pull a 2 out of our denominator. Negative 2x will be left here. And plus y will be left here. And then our 2's will cancel. So we'll just get dy dx equals negative x plus 2y over negative 2x plus y. So the interesting thing here, notice that we've essentially found the derivative of y with respect to x, but the equation for this has a bunch of x's and y's in it. We don't have an explicit formula for the derivative of y just in terms of a bunch of x's. And the reason for that is because what we started with, we didn't start with an explicit formula for y just in terms of x. That's why it's called implicit differentiation, is because, basically the x's and y's are all mixed up together. We don't have an explicit formula for y in terms of x. Therefore, we have, kind of an implicit function for the derivative of y as well, where the x's and the y's are all kind of mixed up. But if we did have some point, some xy coordinate, where we wanted to find the slope of the tangent line at that point, we would just plug in the x and the y point into this, and that would tell us the slope at that point. So even though it isn't an explicit formula and it's all kind of mixed up together, it still is useful to find, the slope of a function given some function like this, where the x's and the y's are all mixed up together. So hopefully that was helpful for you guys. Go check out some of my other implicit differentiation problems. I'll link a couple right here so you can go, keep practicing this stuff and really kind of nail it down. That's the best way to learn this stuff. So go click on one of those videos, get some more practice, try doing some of these yourself, and hopefully it'll help you learn it. I hope it was helpful for you.